Okay, so let's practice the confidence intervals that we just learned about. So a paper manufacturer expects mean paper length of 11 inches with a standard deviation of 0.02 inches. The inspector measures a sample of 100 sheets of paper and finds a mean length of 10.998 inches. Find a 95% confidence interval for the true population mean paper length of the manufacturer. Okay, so let's just write down some of the information we were just told. So we were told that N, our sample size, it will be 100. We were told that our sample average, X bar, was 10.998. Right, the 10.998 came from the sample of N equals 100. We were told that the standard deviation, sigma, was equal to 0.02. So here we have 95% confidence. So that would imply alpha is equal to 1 minus 0.95 or 0.05. And so alpha over 2, because we always divide alpha over 2 for confidence intervals, would be 0.025. And then z.025 would be 1.96. This was one of the values I listed in the prior video, z.025. Okay, so now let's do our 95% confidence interval. Okay, so I'm going to rewrite our formula, which is x bar plus or minus z alpha over 2 sigma divided by square root n. So let's go ahead and just plug in all of our values. So our x bar was 10.998 plus or minus. So here, z alpha over 2, right? Z alpha over 2 is just z.025, which is 1.96. So I'm going to plug in 1.96. Sigma, that was given to us, was 0.02. And then our n, so square root of 100, because n was 100. Okay, so 10.998 plus or minus. So if you plug that into your calculator, you get a value of 0.00392. And then if you take 10.998 and subtract 0.00392, you get 10.994. If you take 10.998 and add 0.00392, you get 11.00192. Okay, and now we're ready to interpret this, which is I am 95% confident that the mean paper length, right? We want to put the interpretation back into the context of the problem. And this problem was talking about paper length. So paper length is between 10.994 and 11.00192. And that's it. That's how we do a 95% confidence interval. So we just write down our relevant information that was provided to us from the problem. And then we just plug into our formula and we get a range of plausible values. So in this problem, they suspected that the mean paper length was 11 inches. So let's see if that's a plausible value. Well, 11 is indeed between 10.9 and 11.001. And so that means a value of 11 is indeed a plausible value for the average paper length. Okay, so if we were to take 1,000 random samples from the manufacturer, each of those samples was 100 sheets, and we calculate a 95% confidence interval for the population mean sheet length for each sample, How many confidence intervals would we expect to contain the true parameter mu? Okay, well, we're saying we're going to take 1,000 samples, and we have 95% confidence. And so this would be 1,000 times 0.95, or 950. Because this is our other interpretation of a confidence interval, is that 95% of our intervals will contain the true population mean mu. So what would happen to my confidence interval if I calculated a 99% confidence interval? So everything remains the same. So same x bar, same n, same sigma. And if you want, go ahead and pause the video and see if you can create the 99% confidence interval. In the meantime, I'm just going to snag some of this. So same information, but now let me change some things. So instead of 95% confidence, I now have 99%, so our alpha becomes 0.01. And then when we divide 0.01 in half, we get 0.005. So we're going to want z.005. And this was another one of the values that we listed in the prior video. And this is 2.576. And now we want to create a 99% confidence interval. So our formula remains the same, it's just now we're using a different z value. Since instead of z.025, we're now using z.005. So x bar is still 10.998 plus or minus. So our z is 2.576 times sigma 0.02 over square root of n, which is 100. So plugging this into our calculator, I get plus or minus 0.005152. So I get values between 10.9928 and 11.003. Sorry, I'm lazy. I don't feel like rewriting the entire interpretation, so I am going to cheat and just copy and paste. So I am now, instead of 99 or 95%, I am now 99% confident that the mean paper length is between, so now I need to change these numbers as well, is between 10.9928 and 11.003. There we go. We've now done a 95% confidence interval and a 99% confidence interval. So let's just notice a couple things. So I've just rewritten our confidence interval. So our 95% confidence interval was from 10.9 to 11.001. And our 95% or 99% confidence interval was from 10.9928 to 11.003. So I just want to note that the 95% confidence interval is wider, right? The lower bound is smaller than this lower bound, and this upper bound is bigger than this bigger bound. So it's a wider interval. And so our 95% confidence interval is a little narrower than the 99%. So that makes sense, because if we want to be more confident, let me move this up, right? If we want to be more confident that the interval contains mu, this is the population parameter we're interested in, then we can just make a wider interval, right? The wider the interval becomes, the more likely it is that mu will be in that interval. Thus, as our confidence increases, the confidence interval will get wider. So that'll always hold true. If we're holding everything else constant, the more confident we want to be, the wider the interval will become.